Okay, so yeah, hello everyone. Yes, I have opened the PPT uh, for explanation, but don't worry, I'm not going to bore you with the detailed explanation. Okay, so what we will do in this video is we will be going through mainly three things. The first one is why exactly we chose this to be our final project, what we wanted to build till the end, and what we have built. Then I will take you through the application. We'll show you some features, most of the features. Okay. Then at the end we will see few demo videos. So basically, I would like to take you through the entire process in as minimum time as possible. But still, the video is going to be a little bit lengthy. So please bear with me. Okay. So yeah. So the project name is BlockMeet. So what it is, it's nothing but a video conferencing application that we wanted to create. Why we wanted to create it? Okay. So yeah, so this is our team, mentored by our HOD, Dr. Sachin Bhujwa sir. Okay. So yeah, let's just skip to the main part. Okay, yeah. So right now, the application that we have, right, like Google Meet, Zoom, Microsoft Teams that we usually use. Okay. So what is their architecture is that? So they have something called as an SFUs. Okay. So as you can see, this part, the central part, this is an SFU. So what normally happens there is, so when we join a meet, what we exactly do is we get connected to this SFU. Then we transfer our audio and video stream to this SFUs, and this SFUs just in just I'm just talking in very layman terms, okay? So what they do, they just take our video and audio streams, they combine it into a certain, let's say, packet, and then broadcast it to the all the participants of the meet. Now, this process of catching the video and audio stream is very expensive process. It like requires very large computational powers. Okay, and yeah, this is normally how it happens. But due to which, what happens? As I told, all the audio and video of a meet goes into a central place. So means at that point we have, let's say, a centralized authority which can access their audio. They won't access, but they can access it in most of the situation. And we wanted to create an application where the data of the streams, the audio or the video streams, just remains within the groups. And by that means, we wanted to create this application. And yeah, so this the architecture that you see right now is for Zoom. Okay, yeah. So the other architecture that we normally see is this type of architecture, which is like a super peer network. So in which what the organization do is rather than having just a single centralized unit, they have multiple units. Those belongs to the organization itself. For example, this is the architecture used by Skype. So you can see they have like this four super nodes, and all the we can say participants join to these super nodes. They transfer their data to them, and these super nodes are connected in mesh network, and then they just share the information, and it is broadcasted back to everyone. Okay, so this is the next architecture that most commonly they use. Okay, so by observing those two architecture, we find it okay, yes, okay, this is good. That was also good, but still we have a centralized control over the data. The data that we are sending is not completely safe. It can be accessed by others, and which can lead in results into we can say the loss of privacy. Yeah, the privacy is in danger, and we wanted to create something via which we can stop it. Okay, so that was the main agenda. Create an application in which the data that we transfer or exchange between us remains only within ourselves, within only the participants of the meet. That was the main motto. Okay. Okay. Yes. So now, what is the solution for that? Obviously, decentralized network. Yeah. So when I firstly heard this idea, what the first thing that came into my mind was the you remember the decentralized internet from Silicon Valley. Yeah, but none of us was Richard, and we couldn't uh, build that high compression algorithm, lossless compression algorithm. So yes, we were left with this challenge to create this application. And yeah, so then we thought of some things and came up with a solution. So what was our solution? So let me just skim through this PPT where we enter the solution. Yeah, okay, the WebRTC part. So of course, WebRTC is essential. This is the protocol which transfers the real-time data across the web, and mostly video calling operation, maybe whatever application you might be using, it's mostly uses WebRTC protocol. It's just a standard, like for transferring data, we use HTTP protocol. For this real-time communication, we use mostly WebRTC. Now, okay, this is just some stuff about the WebRTC. We will just see how we have limited in the predictions, and these are some other features, but we will just skip to the part of architecture of our application. Yes. So, what is our architecture? What makes our application special is that uh, rather than being dependent on a powerful centralized unit which can do the task of highly computation, what we have chosen, we have built or created something which we like to call is hydrocarbon inspired architecture. Okay, so this one. Okay, this one is the correct image. Okay, so what we do is, so you can see here we have some green dots and some yellow dots. So what happens in our architecture is when a person, uh, when we create a meet, automatic, then how exactly this thing happen? We'll see in the code, we'll see in the project application. But right now, just to understand this thing is that when a meet is created, we initially only take things such as we have to give like who are the members who are going to join in this meet. So we have the number of members that are going to be part of this meet. Then we have created a formula which is nothing but called as super pair factor. So and the formula is pretty simple. The number of nodes divided by 3, the seed of those that value. And by obtaining this, we calculate how many super pair we require. And then a hydrocarbon like structure is created where we have super pair and the normal pair are attached to those pairs. And these super pairs now transfer the data among themselves. What happens due to this is first thing, the heavy task which was normally done by a central unit which was owned by that company or the application that you were using here, those tasks is distributed among the uh, the participants of the meet itself. And as you can see, not very high number of uh, peers are connected to that super node. It doesn't also require very large computation power, and we can distribute that large amount among the participants. Okay, so what I'm talking about the computational power, I will also attach a video at the end of this video. Okay, that it shows that what exactly happens when you try to connect very high numbers of super pair, how the CPU computation usage increases even in your devices. Okay, so yeah, so this was about the architecture. So summarizing the architecture, it is a hydrocarbon inspired architecture in which we have super pair, we have normal pair. As the is meeting is created, we first fill the super pairs and then we then attach the normal pairs to each super pair such that in the following in the manner that we can see on the screen, due to which a very simple kind of architecture is created and the data is transferred within themselves, due to which we don't require any external entity which can collect the data and broadcast it again. And yeah, so that was the main part. But we have many other things as well. So for that, let's just dive into the demo. Demo means the walkthrough through the project. Okay. So yeah, so here we are. So this is the application itself. So let's start from the beginning. Just let me just sign out. Okay. Okay, just let me just find complete Wi-Fi. Yes, I'm connected. Okay. Okay, so we have pretty basic UI. We didn't want it to do anything fancy. Okay. Or we okay. So we have really basic sign up sign in. So for sign up sign in, we have for authentication, we haven't used any external you know external feature. We have just used JWT. So let me, for authentication and authorization, let me just sign in. So I have this, I have already created few accounts and let me just sign in. Okay. So for those who don't know what JWT is, JWT is, we can just putting it in the simple words. What JWT is, it's just makes your work of authenticating and authorizing someone very easy. So why it is required? Just imagine, just not about this easy to explain when you consider mostly the authorization stuff. So just a second, give me a second. Let me just drink some water. Okay. Okay. So what I was saying is about the JWT. So JWT is more easy to explain when you consider the authorization part. So why authorization is required? So imagine you have an application which has multiple routes. It has multiple features. Now it is not that all the features are allowed to be used by everyone, right? So you need to authorize. Okay, if someone tries to use some features, then you need to know, okay, if that person is authorized to use it or not. And if you try to always rely on the username and password, it will be like unrequired database feeding. Okay, okay, right? And you have to do it every time, right? Similarly, it can be used, JWT can be used for session management. Like you have to, every time a person opens your website, you have to again log in, right? Or otherwise, you have to store your password and username in the cache. So that is not a solution, right? So something like you have to do. What a JWT, so just in simple terms, JWT gives you, and some, let's just for the sake of understanding, a magical string which can be, let's say, solved, or which can be known, or which can be verified by your server only, that if that string is correct or not. Okay, I don't know if that was a easy to understand explanation, but I'll show you. I'll show you what exactly JWT string looks like. Okay, I think I have logged somewhere here. Okay, just a second. Yeah, okay. So see, this is an JWT string. So now this JWT string was created by my backend, right? So there is something like, while you use this, you provide you something called as your JWT secret and salt. Okay, and using that, this was created. And you can see here, this is something that this content of this actually string, which has the ID, an email, and there's something which is it uses for checking purpose. Okay, and if at the end my backend is able to recognize this is equal to this, and for that purpose this helps it that if it is a recognized correct or not, then it says okay, this string is correct and it belongs to a valid user. And if that is my backend is unable to understand this string, then it is told that okay, this user is not allowed to do particular operation, something like that. And the thing is, it's not some, it's very largely used technology. Not only us, but let's say the widely used applications so far. ChatGPT, it also uses it. I'll just show you. Okay, okay. So I'll just use it. I'll just show you how it uses it. Let me show you. I'll just go network. I'll just set something high. Okay. So in the conversation, if I will go to here, I will go into requested headers. Yeah, you see this one, authentication bearer. Yeah, this is the GWT token. Actually, the length of their token is pretty large. By the way, don't you shouldn't share this token with anyone. But I will just again log in. Okay, and just a second. Okay, sorry for that. Okay, so you can see here, this is the GW token which ChatGPT was using, and you see this is my actual email and all the information that they need. You see the length of this is different because they are using different algorithm. They are using RS56 for hashing, but I have used Bcrypt library, which I think uses HS56 or something. Okay, but that's enough. Okay, so that was about the side setup. And you can see about the UI, we have pretty basic UI. We just have here two options. First, add a meeting and join a meet. So when we want to create a meet, what we want to do is nothing but we have to just simply write a name for a meet. Let's say demo meet one. Then what we have to do is, now this is the thing, we have to actually know the mail ID, or the mail ID which your let's say colleagues have registered in the application. So you need to enter it. For example, I'll be adding all the email that I want to write. Okay, so okay. Then I have to click on add here. So it will just check it if this user already exists or I'm just typing anything garbage. Then I will just add one more. Okay, so it has added. What would happen if I just do something random, type something random, and if we try to do this, the user does not exist. So you have to enter someone which has already logged in or signed up, you can say. And once you have added everyone you want, you just create the meet. Okay, and yeah, meet has been created. Now this is just a simple process. This is how you create a meet. Now its next part is joining a meet. When you click on join meets, you will see all your meets here. Okay, so right now we created this meet and it is visible here. Now if I will go to the second account and that he will also be able to see it. Okay, so we will join the meet later. Now we will see these other features that we have. So the next thing that we wanted to add in our application was a storage, right? So if you are using some application for let's say having a conversation with someone online, then or some discussion, then you would like to share some document, right? And for that, like similarly, we have in our Microsoft Teams. And for that, there is an option of a basic database, but we wanted to make it as decentralized as possible. So for that, we have used IPFS. IPFS stands for Interplanetary File System. So it is very an amazing thing. Okay, so you would see that we have that is just a second. Uh, just a second. Where is it? Okay, yeah. So, okay, just I will just explain it in very short. So what it is it's just what it does. It's if you upload some file here, what happens is you will that file is gets broken into various chunks, and that chunks are then stored across the various nodes which are present in IPFS cluster. And if you want to access those all files, you require a certain hash. And if you have that hash, then it combines, then we can reach to all the files. It combines it using that hash, and then you can access it. So no one can access a particular file without having that hash, and the files are not stored entirely. These files are stored in chunks, due to which if even let's say my laptop is a part of IPFS cluster, then stored file because I don't have the hash or the file itself is not complete. Okay, so that's how we have also integrated IPFS here. Let me show you. So if I click this file, so it will take me to this page where you will see all the files that have been uploaded here. So okay, just a second, give me one more second. Okay, so yeah, so you can see this is the IPFS storage that we are providing. So this file you can okay, so I will just show you uploading one file. So if I click on upload a file, for that you have to first enter a file name. Let's say demo one. It will ask me to choose a file. Okay, so I'll just choose a random file. Okay, I'll just using this random photo. Okay, I'll be just have choose it. Now I'll upload it. Now see it will take some time. So what is happening here is the entire process that I have told you, the process of oh it got okay, but completely quickly because I guess the file size was very short. Okay, but what is happening here is uh okay, everything is done. So what is happening here is the file got broken into chunks. It got distributed among the IPFS cluster, and we got a hash using which we can access it. For example, if I clicked on this file, you will see. Just look at the URL. So yeah, Pinata Cloud. This Pinata Cloud is okay. Okay. This is one of the question I guess I had solved some time ago. Okay. If I open the next file, I will get okay. Yeah. So this is GB Zoro, the GB form of Zoro. So here I have used Pinata Cloud, which is an external service which makes it easy to store your application to IPFS and retrieve it. For that, you just need the hash, and we have to store that hash. And using that hash, we can access those files easily. And so no one except the person or people who have this hash can get access to those files. Okay, not even the company itself. Okay, so yeah, so this was the IPFS feature where you can store your files, your PDFs, or maybe in that case videos. But the thing is, the service that we are using, we are having limited storage here. So let's not upload any larger files. So recently we can upload or store these things decentralizedly. Yeah, so this is one of the features. Next thing, the next thing is something we can say, oh, I know that it is overkill because here here we have given the feature of logging, and guess how we are storing those logs? We are storing those logs on blockchain. Yep, yep, yeah, yes, we are using blockchain for literally logging purpose. So why we did? Just we wanted to explore uh, blockchain and create an immutable log that we all know, a generalized definition of blockchain. So what we are doing here is whatever a person does with respect to a meet. For example, I am a participant of that meet, and whatever activities I do regarding that meet. For example, I have joined a file, I requested the file, I opened a file, or I uploaded a file, I joined the meet, I left the meet. Everything is logged here, and those things are stored on blockchain. Which blockchain you ask? Then we are storing it on Polygon testnet. Okay, and if you click on this URI, you can actually see the details or that log particular stored on blockchain. So you would see here, show more detail. Okay, this is the data stored. If we just click on original, okay, okay, UTF-8. Okay, you see, okay, this was done by this ID. This task was opened this particular file, and it was done by me myself. Everything is logged here, and for that we are using yeah, to writing the smart contract here. For this purpose, we have used hard hat framework. Yeah, Ethereum framework. Okay, and yeah, this is the simple smart contract which does nothing but logs its code, logs whatever actions are being taken place on the blockchain. So yeah, this was the logging feature. Uh, okay, and yep, I guess what else? So the main IP that our project had was the part of where you can create a meet which is completely decentralized. And yeah, we don't use a mesh architecture. Uh, a mesh is basically, we have all learned in CN, a mesh type of thing, but we have also seen the drawback. It requires large number of resources in here too. If we try to create a decentralized application using mesh architecture, you can't even scale more than 4 or 5. Your PC will begin to lag. But in here we have created a decentralized video conferencing application which is not meshed, and it can be scalable. I think up to 15 minutes easily. We haven't tested it that much. We have tested I think up to 10 minutes, 10 participants. So now let's join the meet. So this is between this user, and I have to open in an incognito mode. I'll just okay. I'll just log in the other user. Okay. So I'll join them this meet two. Uh, I'll just one thing. Okay, just I didn't allowed. Okay. Hmm. What is this? Just a second. I think I have to wait here for some time. Okay, so let's now join the meet. Okay, I'll be joining this meet itself. Okay. Okay. Wait a second. Let me just join a different meet. Wait, meet here. See the part of this meet. No, no, no. Hmm. What is? Okay, sorry, I was trying to access the camera. But the meet was not getting the video stream, and I was thinking what was going wrong. Then I just realized that the reason it was not happening because I'm using the camera for OBS here, so I have to first pause it. So I will just stop using this camera, and then I will join the meet again. Then we will see the next person. Okay, just give me a second. Okay, so I have paused the meet, sorry, paused the my video capture from OBS. Now we will see if everything works fine. Okay, so we will join this one here. Okay, yep, the meet is connected here. Now we will, okay, let me just again open here the using the second mail ID. Now we'll be joining this meet again. Okay, the things
Okay,
are working. Okay, maybe this, otherwise I'll be hearing. Okay, so you see, so we are actually hearing or able to see both the streams which are connected here. It's little bit blur. Okay, but yeah, so right now it's just 2% stream. I have video recorded of more than two people joining the meet as well. I think in one video I have 3 person joining the meet, and in the next one I have up to 7, 8 people inside the meet. So I will be editing those video at the end. Okay, so yeah, this was about the a demo. If you want to try this application out, what can you do? I will just close this meet now. I will let you know. Okay, so from here as well. Okay, yeah, we close this tab as well. Okay, so if you want to try the application now, sign up into the application. If you want, ask your friends to sign up in the application, take their mail, create a meet, and then you can join together. And you would be able to communicate with each other in decentralized manner. The audio and video stream that you are sharing will be shared only among the participants. And yeah, that was our main mode of the application. And we have, I think actually there are lots of bugs in the application. I agree. Um, one important one is that sometimes that when you try to access it via mobile, uh, you don't get the camera access. Sometimes it happens, sometimes it works properly. Okay, so yes, so that was about the application. Next thing is about deployment. So as you can see, we have deployed our application. About the architecture of our application, let me just show you. Okay, so we have like a four-layered architecture for our application. The first one is our client, which is most is written in React, which we just saw in the UI part. We have tried to keep it basic. The next one is the server. Okay, the server which mostly handles the operation related to creating the meet, login, sign up, then joining the meet. Now the next part is our WebSocket server, which is the core part of our application on in which we have written the logic of our hydrocarbon architecture, where uh, the peers in the meet get connected to each other in that hydrocarbon manner way. Okay, So everything is written in this. The next one is the logging part, which is nothing but our smart contract, which has been deployed on Polygon testnet. So yeah, this was our architecture. Then we come to deployment. We have deployed it the client part on Vercel. The server part is also deployed on Vercel. Okay, the server part is also deployed on Vercel. The WebSocket server, we tried to deploy it on Vercel, but the thing is, Vercel is not designed for persistent connection. So WebSocket cannot. So yeah, WebSocket cannot be deployed there. For that, we have used render. Render allows it. So we have deployed it there. And as I already told, the blockchain is deployed on Polygon testnet. It's the process of deploying is pretty simple. You just have to uh, you can easily directly deploy it from your the process is really simple. It's not that complicated for that. Okay. Now we also tried to deploy on AWS. I was also able to help me deploy the server uh, of the application. But the thing is, after deploying, I understood that what we get after deployment is an uh, HTTP based website. And if you want to use our application, it is essential that we are having an HTTPS connection. Why? Because this media access API that we are using from the browser only works when we have an HTTPS connection. So even if we deploy our application on AWS completely, you won't be able to access the video stream. The only way through out of this is we have to get SSL certificate. I tried to get a self-signed SSL certificate, but that doesn't work. I tried for a day, but it doesn't work. There are some ways in which you can get SSL certificate, but it is for a limited period of time. And I don't. I thought it was not worth the effort, but it's pretty much same. So here for this deployment, I have used the server deployment. I have used Elastic Beanstalk. Then for deployment of front end, the client part, I was going to use Amplify. And for deployment of the WebSocket part, I was going to use the Lambda function and WebSocket gateway, API gateway. So, but um, due to that SSL certificate thing, we cannot deploy it there. So we have to be happy with this deployment, the Vercel and render-based deployment. So yeah, so the both the links are available. Links for the both, sorry, not the both. Only one link that is this deployment link, Vercel link. Also, the link for it directly is available in the post above. Now, see the demo of multiple devices and yeah, one more thing. I have added one more video at uh, why I have thanked my friends for allowing me to use their devices uh, for testing purpose. And what happens if we try to just use a single device as a multi-pair, super pair? How the CPU consumption increases rapidly. Yeah, so yeah, thank you. Watch the demo, and I guess see you in the next post. Thank you.
Okay, so right now the meeting is going on between the seven devices. If it is going on between the seven devices, means there are three super pair. So it's continuously similarly many devices can also work. Okay, so you can see this is device number one, two, three, four, five, six, seven, seven is zero. Okay, so see, so this can be, so this can be, I think it can be scalable up to 20 with minimum lag. After that we will feel more lag. Okay, so okay. Okay, so as you can see, the right now the CPU utilization is let's 5%. Okay, so now just see how it rises when I start to join to the meet. Okay, I'm going to join in 3% meet, so there will be like one super pair and two normal pairs. Okay, so let me just first join in this. So I'll be just 3% meet. Okay, this person has joined. Now I'll just join with this. Just keep an eye on the CPU consumption. Okay, how it rises. Yes, it is. So what happened, it is now up to 30. Now when I will click on I will join with another device. Just keep watching it, what happens there. Okay, just let me just mute everyone. Oh, otherwise we will just hear loud. Okay. Okay, yeah. So see, I have joined using three device and the CPU consumption has gone up to 40. And so this is just because we are having one super pair. Now just imagine what would happen if we try to connect multiple super pair on one device. It just goes up to 70%. And one time my device actually got shut down due to high consumption. So it happens. So that's why multiple devices are essential.